What's going on, everybody? Hello, hello, hello. Hopefully everyone is doing well when it comes to the weekend and labbing and all that other good stuff that goes along with it. So, if you did not read the title of this stream, we're going to be taking a look at diving into a pretty cool technology, at least I think so, that is known as VXLAN, or the Virtual Extensible Local Area Network. So we're going to talk about how VXLAN works and some of the details behind it, and go through a couple of practical demonstrations of how to actually implement VXLAN on the Nexus 9Ks. I have this all working inside of Eve, and as soon as I get a chance to export the lab, for those of you that are currently members of the channel, you'll be able to download the topology and some of the initial configs. I'm actually going to be walking through the initial config a lot of these devices as we're moving forward. So I'll be configuring things as we're going, so setting up the interfaces and stuff like that. So yeah, now there's some CVD, Cisco validated designs out there that are pretty good when it comes to the 9Ks and VXLAN and things like that, data center specific technologies. And one of the things that I realized as I was going through is I was trying to build my Eve topology and my labs around the Cisco validated designs. And the problem I was running into was just way too much resource utilization by the 9Ks. They're a hog, CPU and memory. So right now I have one of my servers has 32 CPUs and 256 gigs of RAM, and that thing, this lab, it's not very big, but it puts a hurting on the server. Like 60% CPU utilization and somewhere in the neighborhood of about 80 gigs of RAM. So it puts a hurting on the lab. So if you are looking to lab up VXLAN and on the 9Ks, I suggest you get a pretty beefy server to do all this stuff with. So I'm doing pretty good with what I've got, but then again, 60% CPU on just one lab with what do I have, like 18 devices? It definitely puts the screws to the lab. So like I said, for those of you that have already joined the channel, if you click the join button on the channel itself, or if you're watching a video, click the join button. Pay the $10 a month, and then you'll gain access to the share drive that I provide with all the labs and all the files and stuff like that. So I'm gonna, now that work has slowed down for me, I'm gonna start putting in and building out labs. So if you go in there and check on a regular basis, you'll actually start to see some Google Docs in there that'll literally just be labs that I'll be going through and building as we're going along. So give me 1 second here. All right, so everything is good to go. I'm going to begin diving into the actual explanations of how VXLAN works and the details behind it, because that's one of the first things. Before I can configure anything and dive into how things work, implementing things and getting them operational, we really need to first step up and understand how VXLAN works and why it's used and its use cases and things like that. Because I know when I first started learning VXLAN, I had a really hard time grasping the concept. Not because it's a complicated logic. The logic was actually pretty simple. It's taking layer 2 data and encapsulating it over a layer 3 infrastructure, so that you're basically extending layer 2 over a layer 3 backbone. No different than like OTV would do. So VXLAN and OTV work a lot of the same things, except OTV is Cisco proprietary and VXLAN is an open standard that anybody can deploy. So when we start diving into some of those details, that it wasn't so much the how VXLAN works, that was actually pretty easy to pick up on. It's the details about how use cases and how it's implemented in different scenarios. That was the hard part for me. But after sitting down and going through some of the labs and watching a bunch of training on it and livening it up myself, it's actually sunk in quite well. So I feel pretty comfortable going through and doing some demonstrations on VXLAN. So with that being said, let's go ahead and do a little bit of whiteboarding here. Let me go ahead and actually move this off screen so I have a little bit of room to whiteboard. And let's go ahead and do a little bit of whiteboarding here in the beginning so that we understand all the details that go into getting VXLAN to become VXLAN. So we're first going to take a quick dive into what traditional layer 2 networking looks like, because if you have a baseline of basic layer 2 networking for those things that maybe you're studying for your CCNA or a CCNP and you want to dive into VXLAN and it's really important to understand layer 2 networking, so VLANs and trunking and spanning tree, and then you can transition into VXLAN and things are going to make a lot more sense. So in our traditional layer 2 network, we're going to have a switch, we're going to have another switch, and these guys will be linked together with a trunk link, right? A trunk link is going to allow multiple VLANs to traverse it. If I have PC1 here and I have PC2 here, and I have PC3 here, and I have PC4 here, and they're all physically wired to the switch like that, and they're all in the same subnet. So we'll give this guy .11, this will be .12, this will be .13, this will be .14, and we're going to give this MAC 11, MAC 12, MAC 13, and MAC 14. So it'll be easy for us to see the correlation. What I'm going to do on this switch here is I'm going to see MAC address propagation, right? I'm going to see traffic going back and forth. One of the first things I'm going to see is on port 1, port 2, port 3, and port 4. I'm going to see on port 1, I'm going to see MAC address 11. On port 2, I'm going to see MAC address 12. Over here on port 3, I'm going to see MAC address 13. And on port 4, I'm going to see MAC address 14, right? And that's what you are going to typically see because these ports are all in the same VLAN, right? Let's just for the sake of argument say every port is in VLAN 10 that needs to be there. So you're going to get the MAC address propagation that's going to happen. The switches that are going to be attached to these endpoints are going to learn those MACs. Well, Ethernet is going to be the media. The media. I always forget if it's media or medium, but Ethernet is going to be our connectivity option, right? That's what we're going to be using to physically wire our PCs to our switches and then our switches to each other. So what will end up happening is these MAC addresses will be learned locally. And then in order for MAC addresses to get learned from one switch to another, they are flooded because Ethernet is a flood and learn style technology. So what ends up happening is we have port, let's say 24 here, and we have port 24 here. What will end up happening is the MAC addresses that are learned on this switch will get sent this direction, and the MAC addresses learned on this switch will get sent this direction. So we have equal flooding, right? So what will end up happening is on 24, so port 24, we'll see 13 and 14. And then over here on 24, we will see 11 and 12, right? Because that's what we expect to see, because the MAC addresses are flooded. Everybody's happy. Now, that's all well and great. Now, what happens if I add another link between here? Let's say we double up this trunk link, and we make it something like this. Then we have port 24, and say we do port 23 and port 23, and we put this into a port channel. Okay, so we bundle it together. Same concept, right? Nothing really changes from a flooding perspective. We're just trying to optimize the bandwidth between the switches and allow multiple flows and things like that. Everybody's happy. So in a situation like that, you end up taking the data that you've already learned and you continue to flood it, right? That doesn't go away. Now, if I decide to add another switch, let's go ahead and draw a switch up here, right? And we'll bring this guy down here. And we're going to say this is port 22. This would be port 22. This would be port 1. This would be port 1. And let's say I have PC 5 and PC 6, right? So port 5, port 6, everybody's happy. The flooding continues, right? It doesn't really make much of a difference. Now, here's one of the caveats to this. This is where spanning tree protocol comes into play, right? Spanning tree protocol, and this guy here, he's going to start doing STP, he's going to start doing STP, and he's going to start doing STP. Well, what's going to end up happening is you're going to have a BPDU sent out here. It's going to be learned in, flooded out that way, flooded out that way, flooded out that way. and returned. That's how a loop is detected, right? So what's going to end up happening is one of these ports is going to get blocked. So maybe this one gets blocked, depending on the scenario at hand. So I'm not going to dive into how SDP figures that out. That's another video, another topic you guys can dive into. But the loop is detected, right? And when the loop is detected, a port's going to get blocked. So think of a larger infrastructure. Let's say you've got a lot of your access layer switches are physically wired to your distribution switches, right? Well, what's going to end up happening is, let me go ahead and get out of the way. If I have a scenario like that, I have to move my mouse. If I have a scenario like that pop up, let's say I have my access switch here, I have access 1, I have access 2, and I have access 3, then I have distribution 1 and distribution 2. And we have these guys all wired up like this, right? And then distribution 1 and distribution 2 are wired together, port channel like that. Well, what's going to end up happening is you will end up having a number of links blocked. So this link would get blocked, this link would get blocked, this link would get blocked. Actually, let's take that one step back. So let's say that one stays open, then on this guy here, this link gets blocked, but this one stays open, and let's do this one. So you end up running into a situation like that where you can take your data flow, so this guy can go to this way, this guy can go this way, and come down here, and stuff like that. So he can get to where he's got to go, but because of the fact that you've got links being blocked, that's where you run into problems. Because now you are limiting yourself on throughput, you're limiting yourself on data flows and things like that. So in the reality of it, and I'm going to have to cover it over just to talk about this for a second. When you run into scenarios like this, the moment you start blocking ports and limiting yourself down to a single data flow, that's when spanning tree protocol starts to lose its effectiveness. Because now, if you've got one 10 gig link versus potentially multiple flows of 10 gig, that's where the problem runs into play. So let's talk about how this actually comes into play in a modern environment. So if I have, we're going to switch gears a little bit and start talking about the VXLAN specific terminologies. So the first one we have is a spine, and we have the leaf, right? And the spine leaf is analogous in operations to the distribution, I'll say distro, and the access, right? They correlate. So you know you can translate one, the 2-tier or the 3-tier architecture of the core distribution access or the distribution access, depending on if you're running a collapsed core or not. You can translate that same understanding over to this, right? Because the physical wiring and things like that aren't changing a ton, just a little bit of a modification to an existing understanding. Where what we're going to be doing is we're going to have some access layer devices that are going to be physically laid out like this, and then you're going to have your spines up here, right? So spines are going to be the backbone, and your leafs or your access devices are physically going to wire into your spines. Now here's the rub. There is no direct connections between your spines, and there's no direct connections between your leafs. So in other words, what ends up happening is if I want traffic to go from leaf 1 to leaf 2 or leaf 3 from spine 1 or spine 2, I have equal cost flows. I can go this direction, or I can go this direction, which is cool. Or if I want to go over to leaf 3, I can go do the same thing. Go up here and come down. I can go up here and come down. That's really the beauty of how this comes into play. Because what's happening is in between the spines and the leaf, you're no longer doing straight layer 2. There is no trunking. Trunking, gone. Spanning tree protocol, gone. You don't need to run either one of those technologies. Why? Because in the core here, all these links that are connecting your spines to your leafs are all layer 3 connections. They're all routed. So what that allows you to do is to take advantage of equal cost multipath, or ECMP. So what ends up happening is each leaf has a loopback that's configured on it, and each spine has a loopback configured on it. And the idea of the loop of these guys right here is a point that you're going to connect to. So when we talk about the leaf-to-leaf communication, eventually the loopbacks will be tied to the VXLAN tunnel endpoint, or the VTEP. The VTEP is what does the encapsulation and decapsulation of any type of VXLAN encapsulated data between the leaf switches. Because remember, the leaf switches at this case here are not layer 2 adjacent to each other. There's no trunk joining a leaf to a spine that connects from a spine down to a leaf. All that stuff is gone, right? It's out of the picture completely. What you end up getting is a routed infrastructure, the underlay. So all this stuff right here is the underlay. And one of the things that I highly recommend everyone do, that if you're diving into VXLAN and you're trying to learn it for the very first time, or this is a new concept to you, is you really need to understand how dynamic routing works, and specifically OSPF or ISIS. You can use EIGRP. It would work because at the end of the day, you're just trying to propagate routing information. But more often than not, when you start diving into these type of infrastructures, a link state database routing protocol, OSPF or ISIS, are going to be the way of doing it, because they all mean, you get a flooding of the routing information and stuff like that, the link state database, the link state packet database with ISIS. We're going to be doing OSPF because it's just what I'm going to be using. If you guys dive into an ACI environment, or if you dive into, I believe SD Access is doing the same thing, you'll see ISIS. So at least that's what I've read and what my understanding of how they work. That's what you're going to see in the underlay. But the underlay is routed, and you're using the connection, the routed connections between the leaves and the spines in order to propagate the routing information, specifically the loopback information, in order to provide that connectivity back and forth. So that's where that comes into play. Now in my lab, I'm not doing dual spines. I'm not doing multiple leaves. I'm doing one spine and 2 leaves, for the simple fact that I want to limit the amount of resource utilization that's happening. Nothing more than that. So the idea that we are going to be basically implementing is taking the infrastructure that we have right now and the logic that we've laid out, and we're going to be installing it here and on here and up here. Now, what specifically are we trying to accomplish? One of the things that we're going to be diving into is having to understand how the VXLAN encapsulation process comes into play, because that's really, really important that we dive into those details, because in the event that you're deploying this and you're like, okay, I need to make sure that the encapsulation is working correctly and stuff like that. These are specific details that you need to really understand. Once you have that locked down, and the VXLAN encapsulation, the packet walk process and things like that, that really will help glue the details of this together for you. At least it worked out really, really well for me. But that's basically how that is going to play out. Got a couple of questions in the chat, so let's go ahead and see what they are. Yes, I will be covering FlexVPN in the near future. I chose not to do that this week simply for the fact that I have been doing a lot of VXLAN lately, and I figured I'd just take the information I was learning and pass it on. Okay, so you use OSPF for your duals. Okay, that's cool. Yeah, that's the beauty of this. You don't have to go one direction or another. You can roll with OSPF if you want to do that. I personally feel more comfortable with OSPF, but ISIS is actually pretty easy to use as well. So let's go ahead and talk about the actual encapsulation process and how that works, because I found that once I did some reading and watched some videos on how that worked, it really helped glue the concepts together. So the idea is actually pretty simple. But when you have traffic from any one of these devices here come into the switch, what will end up happening is this is what would be referred to in the process of a bridge. The concept means that if you are sending traffic into the switch inside the VLAN, you're receiving layer 2 communication inbound. I would prefer to go with BGP. Oh, you're talking about BGP in the underlay? I haven't personally tested out BGP in the underlay, but you know, to each their own. Is VXLAN and hardware the way to go? So that's actually a good question. I honestly don't know. What I have seen is when you're dealing with Nexus 9Ks and some versions of, was it Nexus 5600 or Nexus 6000s, they do it in hardware. So that would be the way to go. Obviously, hardware is going to forward faster than software, obviously. I'm pretty sure that NSX does it in software, but beyond that, I don't know much beyond that. I haven't spent a lot of time in NSX to be honest with you. So, but do I speak Spanish? No. Poquito. My Spanish is really bad. You definitely wouldn't want me trying to speak Spanish. I would butcher whatever I would say. So we have the traffic coming in from any one of these endpoints. It's going to be a bridge. It's layer 2 traffic being received inbound. And then when the traffic is, when you don't know where you're trying to go. So for example, if I'm trying to ping something over here, you know the IP, but you don't know the MAC address. You need to have some sort of way of taking that information, that ARP communication, and being able to send it over here. Well, there's a couple different ways that you can do that. The first way is with a unicast underlay, meaning there's no multicast deployed, and you can use IR, or Ingress replication, which basically is a static mapping from this guy to this guy, and they point to each other. Now, when you configure Ingress replication, you do that on a per VNI basis. And we'll talk about the VLAN to VNI to VTEP mappings here in just a second so that it ties together. You have that. So if you've got a lot of switches and every one of your switches doesn't have all the VLANs created, obviously you wouldn't have to point to every VTEP in order to get the job done. In this case here, we will be. The other way is with multicast. When, sorry, but you have multicast is used in order to take care of the bum traffic. So you have broadcast, unknown unicast, and multicast traffic. That data is, you need to be able to propagate that information some way. And when you're dealing with ingress replication or multicast to take care of your bum traffic, and you don't have BGP, the layer 2 VPN, EVPN address family deployed in order to start to scale your VXLAN deployment, your propagation of MAC addresses will be done in the data plane. So for those of you that have a background understanding of how MPLS layer 2 VPNs work, with say either point-to-point pseudo wires with XConnects or with the or with VPLS or HVPLS for hierarchical VPLS, data plane working. The data plane is how those technologies work as well. So you end up learning a MAC address inbound on a service instance, and you end up taking that data and you replicate it over the pseudo wire to the remote tunnel endpoint that you're connecting to. So you're the remote layer, the remote connection of your pseudo wire, and that MAC address shows up in the bridge domain. Where when you start deploying BGP as the control plane mechanism, then you move away from, with BGP L2 VPN, EVPN, you move to a control plane based learning. So I learn the MAC address in from the endpoint. It's encapsulated in what they refer to as a type 2 route. So this is going to be a MAC advertisement route. So I'm going to put AR for short. And it's sent to the route reflector. This guy will be a route reflector here in a minute. And then that information is propagated down to here as a MAC advertisement route. So you're advertising the MAC address at our next hop in order to reach that MAC address. So think of it like layer 2 routing. It's basically what you're trying to accomplish. And by doing that, you're going to know how to recurse to figure out where to send that data. So that's basically where that's going to come into play. Now, when we start digging into how more advanced configurations with VXLAN comes into play, that's where you're going to start getting into the do I want to do Inter-VXLAN routing, which is 100% possible using a technology known as symmetric IRB, or integrated routing and bridging. My goal is to dive into that and do an example of how that works, so we can get VLAN 10, 11, and 12 or 20 to communicate with one another. That also allows you to take and start deploying external connectivity. So if you wanted to connect outside of your VXLAN implementation and start relying or leveraging external routing, so you take a border leaf and you connect it to an edge device, and you want to bring external traffic into your VXLAN deployment, that's definitely something else that is very possible of doing. Now, there's a couple of pieces that I have not spent, I've played around with getting to work. One of those is going to be multi-site, which is what you have above my head. I have a secondary site here that I've built out where you can basically take one site and extend it to a second site and then use BGP in order to propagate that information. I was able to get the control plane to work, but I have not been able to successfully get the data plane to work. So that's a work in progress, obviously. So with that being said, let's talk a little bit more about how VXLAN ties to the VLAN, because that's really, really important that we figure that piece out and understand those details. So normally when you create a VLAN, you're going to create it, if you're like me, you give it a name. I usually name it like the VLAN itself, unless there's a specific use for it, for voice or wireless or management, or take your pick. Give it a name. On a Catalyst switch, this is as far as you go, right? Depending on the version of Catalyst you're working on. If you're on like one of the newer ones, I'm sure VXLAN has a supported capability, but the access switches that I have that are Catalyst based, VXLAN is not supported. So what ends up happening in Nexus is once you enable the appropriate features for this to work, you'll see the VN-segment command. And this is going to allow you to associate a 1 through 16.7 million VLAN ID to it. In other words, you're going to be able to take one of potentially 16.7 million VXLAN identifiers and map it to the VLAN. So you would say VLAN 10 and you would say VN-segment, let's say 10100 or 10010. So maybe that's what you decide to use. If you're in a multi-tenant environment, you might take advantage of trying to be specific to the customer and then give them their 4,000 VLANs. Or if you're working in if you're not working in a multi-tenant environment, maybe you're just working in a regular customer environment where there's only one customer to deploy, and you can use whatever values you want. Some people use 10,000 as a segment identifier. They might use 11,000 for VLAN 11 and 20,000 for VLAN 20. It's really up to you on how you want to go do it. So the idea with these bits, and actually there's a comment on the details here. So here we have 12 bits, right? So which gives us a total of 4,096 total VLANs. With VXLAN, we end up getting 24 total, which gives us about 16.7 million total VXLAN IDs. So this is a one namespace, this is another namespace. So when you're creating a VLAN, you map it to a VN, or VXLAN network identifier. So it goes VLAN to VNI, or VXLAN network identifier, and then that gets tied to the VTEP, or the VXLAN tunnel endpoint. This right here and this right here are technically mutually exclusive, meaning that I can create VLAN 200 but use VNI 1001 or whatever value I want. They don't have to match, is what I'm trying to say. So I can use whatever values I want. The key thing though, when you're dealing with this, is making sure that you understand that, and this was one of the, I got tripped up on this when I first started learning VXLAN several months ago. I was under the impression that when I'm configuring, I map a group of VLANs to a single VNI. And I didn't understand how the scale worked on every switch. So for example, I was under the impression that I could configure, I thought it was going to be a VLAN to VLAN to VLAN mapping, where I had to have all the VLANs configured on all the switches in order for this to work. As how else would that play out? Which actually wasn't the case at all. So what's cool, what ends up happening with VXLAN that comes into play, and this is what, it was actually a lengthy conversation with a DM communication on Twitter with a friend of mine. And he's just like, he's like, you're missing something here. He's like, what you're missing is that it's not a multiple VLAN to single VNI, it's a single VLAN to a single VNI. It's a one-to-one mapping, which means that I can have a very, very large deployment and I can scale this as big as I want. So if I've got 100 switches and I've got potentially 1,000 VLANs deployed, I don't have to configure all those VLANs on every switch and have trunk links connected to everyone in order for the MAC address propagation to work. That's the beauty of it. I can configure on that switch what VLANs I need to have, associate VNIs to those specific VLANs, and then tie those VNIs to the VTEP and allow VXLAN propagation to happen from there. I was like, oh, wait, I don't have to, because I was still stuck in a layer needing a trunk logic. I was like, no, you don't have to do that. So if I have, say, for example, one switch that's got 10 VLANs on it, and I can have 1 through 10, and then the next switch in the next rack has VLANs 21 through 35, I would create VNIs for those specific ones, but traffic from switch 1 and rack 1 into switch 2 and from rack 2 wouldn't communicate with each other at all because they don't have any overlapping VLANs on them in order to do that propagation. So now, but if I did have a customer that got added to that switch, I'd create that VLAN that maps to the other one. So create VLAN 8 on switch 2, rack 2. Guess what? Now I create the connection from switch 1, rack 1 to switch 2, rack 2, and now they communicate just for that one VLAN. That's really the beauty of this. So if you can make this scale pretty wide, to be honest with you. The biggest deployment I've seen of this was 8 switches and like 30 or 35 VLANs. I forget what it was. The cool thing about it is there's really no upper limit, right? So you can make this grow or you can make this as big or as small as you want, and that's really the cool thing about it. Some additional things that you can do with VXLAN that I have not tested out yet and actually gotten to work. The first one is the multi-site. I've gotten, like I said a moment ago, I was able to get the control plane to work for multi-site, and the other one is doing service insertion. So you can configure it to pass traffic through a firewall on a remote service leaf. There is the VPC version of the gateway where you end up taking a pair of Nexus 9Ks that are running VPC, bring that down to a server or to a downstream switch. I haven't tested that out either. I'm trying to lock down the setup that I have right now for doing the Anycast gateway, which is what we're going to be doing here when we start getting into the config. So with that being said, that's really where these pieces come into play and become operational. So we're going to go through and begin getting everything squared away and configured and go from there. If you guys have any questions, throw them into the chat and stuff like that, because I've covered as much of the initial config as I want to, or the initial logic as I need to. So we're going to be focusing on Nexus 9K 1, 2, and 3. We're going to be getting the routing up and running. We're going to be using OSPF in the core in order to get this communication up and running. We're going to take a couple different looks at some stuff and make sure that we have everything squared away. I'm going to go ahead and out of the gate turn on all the features that I need to turn on initially, because I don't want to be forgetting a feature that I need to turn on later on down the road. So we're going to be turning a bunch of features on right away, so it's going to slow things down just a little bit for us. But this is going to be a from scratch deployment, so there will be some times where we have to kind of just sit and wait for the devices to do their thing. So first thing, yeah, that's exactly it, Mike. That was one of the things that I had a hard time It's like when you're so used to doing something a certain way, and then somebody comes in and kind of changes, throws some new terms at you and says, well, yeah, you don't need trunks. And you're like, wait, what? How did the MAC addresses get there? So yeah, what is your EVNG hardware spec for the setup? It is a UCS C220 E52650s. I have dual 8 cores. So in this topology, R7 and R9 would have their VLANs declared at layer 2 and speak to each other through VXLAN, who handles the layer 3. So the first part of your question, 100% accurate. So R7 and R9 would be in VLAN 10, would be .7 and .9 respectively. The routing in this particular case would be handled between Nexus 9K1, 2, and 3. They're going to be running OSPF, and then they will be VXLAN aware of each other. There will be a VXLAN tunnel built between 9K1 and 9K3, and that's how they're going to be able to communicate with each other. If R9 wants to talk to R7, he's going to send that traffic into 9K3. The destination will be 9K1, so it'll be VXLAN encapsulated from 9K3 to 9K1. The VXLAN header will be ripped off, and then you'll be dropped off into VLAN 10 in order to communicate with R7. And you'll see this here in just a few minutes once we get it all squared away. So let me go ahead and start this process up. We'll go ahead and log in and get the configuration started. I'm going to go to global config, and I'm going to go to show run interface E1/1. I'm going to type in interface E1/1, give it an IP address of 10.1.2.1/24. Oops. And no shut that. Yeah, using routers as endpoints. Yeah, just no worries. However, to your question, you can actually, because we're extending layer 2 over a layer 3 infrastructure with VXLAN, R7 and R9 could be routed peerings because they'll be able to talk to each other inside the same subnet, and their MAC address information will be propagated. So you technically could do a routing adjacency between R7 and R9. It would work. It'd just be VXLAN encapsulated. And I'll show you what that looks like once we get there. So we're going to go, we've got that, and then I'm going to go to interface loopback 0, and I'm going to type in, give that a couple seconds to do its thing. This can run a little bit slow depending on what you've got going on. IP address will be 10.0.0.1/32. Now in Nexus 9K2, I'm going to go log in there. Now while I'm logging in here, I'm going to be turning on a couple of features. I'm going to turn on feature OSPF and feature BGP and feature PIM. We'll let those go because those are usually the ones that take the longest to load up. I'm going to type in the password here. I'm going to go to global config, interface E1/1. IP address will be 10.1.2.2/24. No shut. And then interface E1/2. IP address of 10.2.3.2/24. No shut. And then I'm going to go to interface loopback 0. IP address of 10.0.0.2/32. There's that. And we can see that that has finished up with the features. I'm going to go ahead and do the same thing there. I'm going to go over here. I'm going to do a show CLI history unformatted for the last 6 commands. Let's go ahead and throw these features in here real quick. Up here. Go to Nexus 9K3. Admin in. Go to global config. And then interface E1/1. IP address here will be 10.2.3.3/24. No shut it. And then interface loopback 0. IP address will be 10.0.0.3/32. And there we go. So I'm going to go ahead and paste in those features, get them started. All right, so now that we have that deployed, the next step we're going to go through and do is get OSPF deployed. So I'm going to type in router OSPF 1. This takes a minute, so just be patient. router OSPF1, and then Nexus 9K3 router OSPF1. Once you have the routing process turned on, we can go to interface E1/1, IP router OSPF1 area 0, and then interface loopback 0, same command. And then Nexus 9K2, interface E1/1 through 2, IP router OSPF1 area 0, and interface loopback 0. There we go. And Nexus 9K3, interface E1/1, IP router OSPF. This is where sometimes it becomes a little slow. OSPF1 area 0, interface loopback 0. Sometimes this goes a little bit slow. And we're waiting. So let's go back to 9K1 and just validate that everything's working. So do show, there is no do command here. So it's supported, but you don't need it. Show IP OSPF neighbor. And we are paired with router 2. Okay, so that finally took. Hit the up arrow a couple times, and there we go. So that's squared away. So now that we have that, if I was to show IP route OSPF, we hasn't formed a pairing yet. Show IP OSPF neighbor, and it's still working on becoming a peer. So once that's done, which should be done here in a few seconds. There we go. Show IP route OSPF. There it goes. So now I have reachability to the loopback of 1 and the loopback of 2, and the link between Nexus 9K1 and 2 is right there, so we're good to go. So if I ping to 10.0.0.1, sourcing from interface loopback 0, I should be able to ping it, and I can. That's a good thing, because we won't really be able to do anything VXLAN wise until we get to that point. Alright, so the next thing I'm going to do is I'm going to turn on some of the VXLAN specific config. The first one I'm going to do is going to be to turn on the feature VN-segment VLAN base, which is going to allow us to associate the VNI to the VLAN itself. I'm going to turn that on. I'm going to do the feature fabric forwarding. That'll take a couple seconds to kick in. And then I also need to turn on the feature of NV overlay. And that'll pretty much be it. I'm going to turn the NV overlay EVPN feature on as well. So give that a couple seconds to finish doing its thing. Again, this is the slowness to this process. So if you're like, wow, this is slow, it's a virtual environment. Get used to it. So I'm going to type in NV overlay. Give that a couple seconds to catch up here. Overlay EVPN. Just like so. So that's pretty much everything that I need to type in. Show CLI history, unformatted for the last 10 commands. We'll grab these few features, and we're going to enable them on Nexus 9K2 and Nexus 9K1. One of the things that I'm going to talk to you guys about real quick is the fabric forwarding piece, and that enables what they call the HMM, or the Host Mobility Manager, which is going to keep track of how the MAC addresses are being learned from the endpoints, so that they know, so VXLAN knows when traffic comes in, knows where to send traffic, and knows how to propagate the details. So this will also allow us to do the Anycast gateway. Anycast gateway meaning when we go to do the layer 3 VNI, that will allow that communication to happen. So in other words, if I was to do the fabric forwarding, I have the option of Anycast gateway MAC address. So I'm going to type in Anycast gateway MAC address and then the value. I'm going to use 001.0001.0001. So that means that regardless of what VNI I'm working on, I will always have this MAC address as what I want to resolve. So think of this like HSRP. So it's not, the switches aren't layer 2 adjacent to each other like you would need for HSRP in order for them to send the hellos back and forth and to all that good stuff, where this is going to allow every one of the switches that's going to be terminating a endpoint to have them resolve the MAC address of any one of the layer 3 SPIs that we're going to be deploying. That's going to be the MAC address that's associated with the SPI. And you associate that as this MAC address to the SPI with the fabric forwarding mode Anycast gateway. So I'm going to take this guy right here and I'm going to plug it onto 9K1. Oops. And plug that in right there. Alright, so now that we've got that deployed, we don't technically need some of these commands on Nexus 9K2 because it's going to be just a control plane mechanism, but I'm throwing it in there anyway. Is the XR support, does XR support VXLAN? The newer versions I think do, but I have not tested it out. And I don't believe the NVE interface config is available. So I wouldn't waste my time on it. The few times that I've tested it, it didn't work. So I believe that's a line card specific config as well. XR's got a different architecture than Nexus. So if you're doing, a lot of times on XR, you're doing control plane specific details, but because a lot of the things that XR does in terms of layer 2 communication, specifically EVPN, that's implemented at the line card level. So you would need to have line card support in order for that to work. So it's like the switch ASIC would need to do that. At least that's from what I've read, that's how it's supported. So I wouldn't waste your time on XR. You would actually be able to do it on the CSRs. I've tested this on the CSR, just layer 2 communication. It works fine on the CSRs. But if you really want to dive into it, Nexus 9Ks, I'm running 9.3.4 code. It supports it pretty well. So just in case you were wondering about all that. All right, now that we have this in place, we have pretty much everything we need to have in play in order for us to begin the configuration of what we need to have. So we've got layer 3 reachability, and I've not enabled multicast yet. Multicast is not turned on. Other than the features enabled, we haven't actually turned on PIM on the interfaces, so we're not doing any PIM peerings or anything like that. I'm going to show you ingress replication over a unicast backbone first and show you what that looks like, and then we'll take a look at the additional config. So the first thing I'm going to do is I'm going to create VLAN 10, and underneath VLAN 10 we're going to give it a name of VLAN 10 just so that it's got a name. And you'll notice we have this VN segment command. I'm going to use this command here, and then you can give it some value. As you can see, 1 through 16.7 million. Gives you a lot of flexibility. So in this case here, I am going to use the VN segment of 10010. The reason why I'm doing that is because if I wanted to test multi-tenancy down the road, I'm using this basically as a way to distinguish customer 1 from customer 2 and the specific VLANs in that customer. So let me take just a minute and explain what I mean by that. This is something that I did not come up with. This is something that I'm borrowing from in some training that I saw, where you have a lot of ranges, right? You have all this to work with. Basically, what I'm trying to do is provide some organization to the VXLAN IDs that are going to be applied, because the most any customer is going to need is going to be 4,000 VLANs, and no customer is ever going to use that many VLANs. So what will end up happening is take this and basically cut it in half. So this side right here is going to be your VLANs, and this guy right here, this one, is going to be your customer ID. Cust ID. So what that means, if I did 1 and I want VLAN 10, I would do customer 1 then 0010. If I want to do customer 1 and VLAN 225, I would go 10225. So because this gives me the numerical value of the VLAN that I want to be able to throw in there, I can do that. So for example, let's say I had customer 3001 that needs VLAN 1027. I'd be able to create 30011027, right? So that falls within inside of that range. So I'm looking at 1,000, 100,000, 30 million. Well, actually, that wouldn't work. 30 million, yeah, that would be a little bit too much, but you get the point, right? You'd be able to start scaling this out in that respect. So that's actually a bad example. So I went a little too high on that one. So, but that's more or less the direction I see it going. Again, this is not how VXLAN works with the VNIs. It's just a way to provide some sort of organization with the VXLAN IDs. That's all. But if you wanted to, a couple times that I've seen this deployed, there's a spreadsheet, and you start off with a certain VXLAN ID, and you work your way down, and then you associate. Okay, this VLAN ID would be, or sorry, this VNI would be mapped to this VLAN for this particular customer, and you scale it out that way. But as you can see, it's not a foolproof way of doing it. Anyway, I'm going to use 10010. So that's that. And then I'm going to jump out of here. I've got the VXLAN association to the VLAN, which is what I need. So if we do a show run VLAN, we can see that the VN segment's been associated. Now I need to go and create the NVE interface. So interface NVE, and we're going to give it an ID of 1. Now this is going to be very similar to that of a GRE tunnel. You need to give it a source, but think of this kind of like DMBPN, where you don't need to specify a destination, right? You're going to be using, well, technically in Ingress replication, you do need to give it a destination, but that's a separate specific command. So let's go, and with Multicast, it's more like DMBPN, where it's kind of like a dynamic approach to it. It's just like, oh, I don't really care who peers to me. Multicast is used to do that. So we're going to go underneath here and type in source interface is going to be loopback 0. And then we're going to specify that it's no shell. We're going to turn this on right away, because if you don't turn it on, VXLAN won't work. What we're going to do from here is we're going to specify the member VNI is going to be 10010. And then underneath here, we have a couple of different options. We can do ingress replication, so unicast propagation of information. We can do multicast. We can do spine, anycast gateway, ARP suppression. I'm going to type in ingress replication. The protocol we're going to be using is static, so it's going to be hard coded. And then we're going to specify our peer IP is going to be 100 or 10.0.0.3. So that's who we're going to peer to. Okay. So that's all we have so far. So let's do a show CLI history unformatted in the last 20. So we have our VLAN segment is configured. We have our VNI, that's with our NVE interface is good to go. So I'm going to go ahead and go on Nexus 9K3. We're going to type in VLAN 10, name VLAN 10, and then we're going to go to VN segment is going to be 10010, and then interface NVE1. Source interface is going to be loopback 0. The member VNI will be 10010, and then the ingress replication protocol will be static and a pure IP of 10.0.0.1. Let's go ahead and exit out of here real quick and no shut it to bring it online. All right, now that we have that in play, the next step for me to go do is I have to apply the VLAN to the port, right? So interface E1/2. This will be a switch port. Switch port access VLAN 10. Spanning tree port type edge. Do the same thing on Nexus 9K3. So interface E1/2. Switch port access VLAN 10. Spanning tree port type edge. All right, now that that's all in play, let's go over to router 7. And on router 7, I have not done anything to this guy. It literally just came online. If I look at the config, we can see that nothing's set up here. Should you add later on the VLAN 11? I'm only doing it one at a time, but I'll show you. It's pretty easy. Do the same thing. So create the VLAN, associate the VN segment, and then map the VNI underneath the NBE interface, and then specify either ingress, replication, or multicast. It's your choice. But you can do them all at the same time if you wanted to. You don't have to do it like I am. I'm going to go to global config. Hostname is going to be R7. I'm actually going to be doing that here in just a minute. I'm going to show you can run multicast and ingress replication at the same time. That's how I tested it. It does work. And that's what we're going to go do. One will use ingress replication, another one will use multicast. I'm going to go to type in no IP routing here, because we don't need IP routing turned on for this. I'm going to type in interface gig 0/0. IP address here will be 10.1.10.7/24. And no shut it. I'm going to type in IP default gateway of 10.1.10.254. And I'm going to save that config. Go to router 9, do the same thing. Host name will be R9. The no IP routing. And then we'll specify interface gig 0/0. IP address will be 10.1.10.9/24. We'll no shut it. And then we'll do IP default gateway of 10.1.10.254. Save that config. Alright, now that I've got that in play, I theoretically should be okay to start sending traffic. Theoretically. If I go over to Nexus 9K1 and I jump out of global config and I do a show NVE peers, I already have a peering up to router 3 because I configured it manually. I hard coded it, so we're in good shape there. You'll notice the learning type is data plane. So if I do a show MAC address table dynamic, I've learned in my MAC addresses already, right? I've already learned everything in, everything's been propagated, everything's been learned through gratuitous ARP and stuff like that. So I should be able to ping from R7 to R9. So let's go test that. Ping 10.1.10.9. And let's see why that's... Did I make a mistake on the IP address? No, IP address is correct. Show ARP. It's resolving it. Let's see why that's not working. Show IP interface brief. Let's go ping 10.1.10.7. There it goes. It just took a little longer than I would have liked. Ping 10.1.10.9. Excellent. So we can ping back and forth, right? So now if I wanted to do like a dynamic routing adjacency, I could do that. So they'd just be encapsulated inside of VXLAN. If we were to go back over to 9K1 and look at the details of the peerings and do a detail and look at it, we would see that it's been up. We're not doing any BGP at the moment. We're using the VNI of 10010, and everybody's happy. There's really not a whole lot more to this configuration than that. To do just the basic ingress replication, that's basically all we're doing. So we're going to go ahead and do the exact same steps, but we're going to do it for VLAN 11, but we're going to go through the multicast deployment first. Because right now we don't have multicast deployed. So before I get into the NVE interfaces, creating the new VLAN, creating the new, associating the VNI to the NVE interface, we're first going to want to go through and get multicast deployed. So PIM's already been deployed. So I'm going to go ahead and just type in interface E1/1 and type in IP PIM sparse mode. And then interface loopback 0, same thing, IP PIM sparse mode. Then we're going to show CLI history unformatted, pipe to include the last 5 commands. We'll just take these. 9K3, same thing there. And 9K2, interface E1/1 through 2, IP PIM sparse mode, and then interface loopback 0, IP PIM sparse. Okay, now that we have that in play, the next thing for us to go do is to hard code a static RP. Not a requirement, because you have other options. You can do BSR, you can do other multicast rendezvous point replication services if you want to. I'm just using a static RP because it makes it easy to work with. On here, I'm going to specify IP PIM RP-address is going to be 10.0.0.2 for the group of 224.0.0.0/4. So basically anything in the 224 range. I'm going to take this config and I'm going to drop it onto 9K1 and then 9K3. All right. So let's jump out of here and do a show IP PIMs neighbors. We're paired with router 2. If I go to router 2, show IP PIM neighbors, I should be paired with 1 and 2 respectively. All right, so now that we have that piece done, the next thing for us to go do is to create the VLAN. If we do, for example, let me just do this real quick. Show IPM route. We can see that we're not learning any multicast groups, right? Because we haven't turned multicast on anywhere except for just at the interfaces in order to form the multicast tunnels between the leaf and the spines, or I should say the leaves and the spine. So on 9K1, what we're going to go do is I'm going to go create VLAN 11. I'm going to create a name VLAN 11. I'm going to say VN-segment is going to be 10011. And then I'm going to go underneath interface NVE1 and specify member VNI 10011. And underneath here we can do the MCAST group and whatever value you want to throw in here. I'm going to type in 224.0.1.11. And if we wanted to throw in there more, we could. We're going to let it roll with what we have. Okay, so we have that in play. I'm going to do the exact same thing. I'm going to show CLI history unformatted last 10 commands. So literally just do the same thing here on 9K3. Go up to global config, paste that stuff in. There we go. So on 9K1, if we were to do a show IP mroute, we're going to see that we're going to have a star comma G entry here. The star being any source, the G being to a specific group that's going to be joining or trying to receive multicast traffic from us. We have an S comma G entry in the mroute table saying that we are a source and we're going to be sending traffic to a specific group. If we go to router 2 and hit the up arrow, show IP mroute, we're going to have the star comma G coming in, so it's going to be taking details in for this guy right here, and we can see our outgoing interface list is 1/1 and 1/2. We have two S comma G entries, one from router 9K1 and one from 9K3, so they're both going to be sources of multicast information flooding and just sending to group 224.0.1.11. Now if we go back over here and do a show IPM route, we're going to have the star comma G entry. So we're basically saying we're going to be listening for traffic from any source that's sending to this group, which is what we need to be doing. And then we have the star comma or RS comma G entry here. So in other words, what's going to end up happening is each one of the 9Ks that's acting as a leaf, they will be both sending and listening for traffic, sending traffic to the group 224.0.1.11 and also listening for traffic from 224.0.1.11. And what that basically is going to do is whenever an update from 9K1 goes out to 9K2 and is propagated down here because it's in the data plane, it's going to be listening for that information in 224.0.1.11. Unfortunately, I don't. In regular iOS, it's easy to test by doing just a ping to the multicast group. I haven't figured out how to do that in Nexus, so to test it, but it does work. So we're going to go over to router 8, and we're going to, actually, let me go back to 9K1 and finish the VLAN config. So interface E1/3, we're going to say switch port. We're going to say switch port access VLAN 11, and then spanning tree port type is going to be edge. All right, good to go there. Next is 9K3, same thing, interface E1/3. We're going to say switch port, and then switch port access VLAN 11, and then spanning tree port type edge. Excellent. All right, so over to router 8, same thing that we did on 7 and 9 a moment ago. So we're going to say host name is going to be R8. We're going to say no IP routing, make it an endpoint, and then we're going to go ahead and interface gig 0/0, IP address of 10.1.11.8/24. No shut it. Exit out, IP defaults gateway of 10.1.11.254. Save that config and go over to router 10, same thing. Host name is going to be R10. No IP routing. IP default gateway of 10.1.11.10. Oh, sorry, 254. And then interface gig 0/0, IP address of 10.1.11.10/24. All right, no shut that. And do right. Cool. Now that we have that in play, the next thing we should be able to do is look over at 9K1, and we're going to do a, give that a second, hopefully it didn't just crash on me. They're both thinking about it. Okay. Show MAC address table dynamic. All right, so we've learned in that information. What did you do? Correct. And we will be actually taking a look at that once we get through the BGP piece, which will be coming up right after this. We'll definitely be taking a look at that specifically. And you're right, single tenancy, it looks pretty straightforward. Multi-tenancy is where things start to get a little bit like, if I can make my head spin physically or turn like this, that's where you're like, oh my God. Yeah, it could be a little crazy. All right, now that we have that in play, we're going to do a show NVE peers, and we're going to say detail, and we're going to see that communication is working the way we need it to, and show IPM route. We're not going to see a whole lot of anything new because there's really nothing to show. I'm going to go to router 8, and I'm going to jump out of global config, and I'm going to do a show ARP just to prove that we don't already have .10 in the ARP table. I'm going to ping 10.1.11.10. And there it goes. It works as expected. We come over here and show ARP. We can see the MAC address has been resolved. We can ping 10.1.11.8. Oops, sorry, not that one. Too many. There we go. So we have communication going back and forth. So far we've taken a look at intra-VXLAN communication, where we are going to be communicating back and forth using both Ingress replication and Multicast for the propagation of data, and everybody's happy so far. So the next thing for us to go do is to do the BGP piece. So we're going to turn BGP on. We're going to go through and do the VXLAN EVPN configuration. This is where things start to get a little bit more complicated. I did this deployment in a POC for a customer not too long ago, and they were pretty happy with the solution. It's when they wanted to scale it is when things start to get a little crazy. So we're going to start off on Nexus 9K2 because he is our route reflector. So we're going to type in router BGP. In this case here, we're going to use 65101, and I'm going to give that a couple seconds to turn on. It is a little bit slow. And then we're typing address family, the L2 VPN, and then EVPN. If you did not already turn the NV overlay EVPN feature on, this would not work. So just keep aware. I turned a lot of the features on ahead of time, so I wouldn't have to be like, oh yeah, I forgot to turn this on. I did that ahead of time. I tried to do, instead of trying to differentiate what specific features do which specific operational configuration options, I rather just dump all the features I know I need to have running at one time into the box, so that later on down the road when I start configuring things, I'm like, oh yeah, that was easy. So we're going to go ahead and continue this process as we're going along. So all is well so far. I'm going to go ahead and now that I've enabled the layer 2 VPN address family, I'm going to exit out and I'm going to type in neighbor of 10.0.0.1. So this is very much like an iOS XR configuration. In case anybody's familiar with XR, this process is a little bit slow. So just be patient with me. I don't know why it goes so slow, but it does. You know what I'm going to do? I am going to turn off some other topologies that I have working in the background, just to hopefully save some resources. And I'm going to turn off DCI 15 and DCI 16 for right now, because we're not going to be getting to multi-site in this session. And I have not mastered multi-site yet, so we'll take a look at that in a later, maybe another series or another session. I'm going to type in remote AS of 65101, and I'm going to type in the update source is going to be loopback 0, and then the address family L2 VPN EVPN. I'm going to go ahead and specify route reflector client, as well as send community both. So we want to send both standard and extended community values. I'm going to do a show run BGP, and I'm going to steal all this syntax right here, and I'm going to hit the up arrow a few times and go to .3 and copy and paste those details in like that. Excellent. So now what I can go do is on Nexus 9K1, go to global config, router BGP 65101, and on here, router BGP 65101, and we're typing in address family L2 VPN EVPN, and neighbor of 10.0.0.2, update source loopback 0. The address family is L2 VPN EVPN, and we're going to send community both. And show run BGP. Take this syntax right here and dump it onto router 3. Just like that. All right. So now that we've got that going for us, we're in really good shape there. Now on Nexus 9K2, if we show BGP L2 VPN EVPN summary, we have our, once the peerings come online, did I not specify the update source? I did. It just has not come online yet, maybe? Maybe I'm just impatient. Well, that's not cool. Why is it saying idle? Show IP route OSPF. I should have a peer to it. Yeah. Show BGP L2 VPN EVPN. Summary. Idle. I'm perplexed. Why does it say idle? I wonder if it has to do with the fact that the EBI is not turned on, but I haven't gotten to that part yet. So normally, let me ping 10.0.0.1 sourcing from loopback 0. I can 100% reach it, which is what I expect to see. Idle. Okay, that's a little bit weird. Anyway, I've never had it go idle before like that, so I'm a little surprised that it's doing that. So what I'm going to go do is not get hung up on that. There's additional syntax that's needed in order for this solution to work, so I'm just going to continue to keep adding config. I don't know specifically what's missing that's causing that, but we'll just keep rolling with it. I'm going to go ahead and use the EVPN configuration, EVPN question mark, and just hit the EVPN config. And underneath here, we need to configure our VNI. So what VNI are we going to allow to be propagated in BGP? So I'm going to type in VNI, and then what value? So in this case here, 10010, and then we need to specify that it'll be a layer 2 VNI. We'll do that, and then underneath here, we need to specify an RD. So a route distinguisher. A route distinguisher just makes the route unique in a global BGP table. So if something happens, it's specified. The RD is actually a 64-bit value that is set in front of either a layer 3 IP address or a layer 2 MAC address so that it makes it unique. So instead of, in a layer 3 VPN scenario, you would have a customer 1 and customer 2 are both running 10.1.1.0/24. Well, customer 1 and customer 2 would both have different route distinguisher values, and you would associate those RD values to those prefixes so that the RD makes the overlapping subnets unique per customer. So I'm going to say an RD auto, and then the route target both will be auto. So show run section EVPN. Excellent. And then I'm going to exit out one level, and I'm going to hit the up arrow and go to here, make this 11. And the RD will be auto, and the route target both will be auto. So show run section EVPN. Excellent. So now what I'm going to basically do is just copy this syntax right here over to 9K3. Before I do that, let's go back up here. That's really weird that it's still hung up. I'll have to see why that's happening. I'm going to go ahead and paste this config in like so. And so that's that piece. And then lastly, we need to go underneath the NVE interface. So show run interface NVE1. And we need to tell it to use BGP. So we're going to type in interface NVE1 and type in host reachability protocol is going to be BGP. It says please remove ingress replication static under VNIs configured for host reachability. So in other words, you can use ingress replication with BGP, except for in this particular case here, because we have it statically configured, it's just like, well, I can't use BGP to propagate something that you guys configure statically. So I'm going to come underneath here and remove this syntax and type in no. And I can actually replace that with ingress replication protocol BGP. So show run interface NVE1, did it not take off? Okay, so let's type in member VNI 10010 and then host reach ingress replication protocol is BGP. Oh, that's right. Host reachability protocol BGP. Let's try it one more time. There we go. All right, so now we have that in play. We are going to do the same thing on Nexus 9K3. Show run interface NVE1. So we're going to go to interface NVE1, member VNI 10010. We'll type in no ingress replication protocol static. Remove that. And then we'll exit out and do a host reachability protocol as BGP. And do the member VNI again, host reachability protocol, I'm sorry, ingress replication protocol is BGP. And that should be all that's necessary. Let me do a show BGP L2 VPN EVPN summary. Wow, it's still idle. Why is that? Show run BGP. Why is that not triggering? Show run pipe include feature. Show run pipe include and let's see, section NV. Are you making these videos that you study for CCISP? No, actually, I'm not studying at all for SP. I'm just been learning stuff in different tracks that I found interesting. Like I covered SD-WAN. I've doing some VXLAN dives in an effort to start to learn SD access. But I was just learning to learn right now. Your config is not correct. Yeah, I've kind of figured that. Just trying to figure out where I made the mistake. I'm like kind of perplexed as to why it's not coming online. Let me check the notes. I made a mistake somewhere, but I don't remember where. Kind of surprised. Let's see, is there anything that I'm missing? Pretty sure I have everything configured. Or not. Something's missing. So we'll have to do a little... I already have it enabled. It's enabled here. That's what turns the address family on. Router BGP 65101, and then I did address family L2 VPN EVPN, right? And that's literally all you have to do. And then the neighbor of 10.0.0.1, address family L2 VPN EVPN. There is show run BGP. Is there anything that I'm missing underneath that? Yeah, that's why I'm like... a little surprised that it's not working. Crazy town. Why is it not working? I am... The what? No. After... No after neighbor. You don't have to do... What? No after neighbor command, you have to do address family? I'm confused. Router BGP 65101. Enable address family after neighbor command? Right, so you type in the neighbor command, and then you type in the address family. Address family L2 VPN EVPN. And that's what I did. And then send community both. Am I missing the remote AS? Oh, you're right. Could I have made that dumbass mistake? You gotta be kidding me. If I made something so junior level. Okay. Let's go ahead and throw that in there. I'm like, what am I missing here? I cannot be making these. Yep, you're right. It happens. Yvonne figured it out. Let's try it now. Okay, there we go. All right. Yeah, CCIE still make mistakes. I'm like, everything looks right, but it's wrong, Rob. It happens. So if we come in here, we'll have... Oh, wow, better open attack case. Well, you guys... All right. I made a mistake. All right, so we have everything working now. Yeah, I am TAC. That's why I have you guys on the live stream telling me where I made the mistake. I would have found it eventually. All right, so let's go over this real quick so we understand what's happening. You do show BGP, L2 VPN, EVPN. We're learning a bunch of stuff in. So we're going to have the layer 2, the type 2 MAC advertisement route, and then we have this other one here. This one here is the the inclusive multicast route because we're using Ingress replication. So if we go over here to 7 and 9, go to 7, and we ping 10.1.10.9, that should work. At least that was easier to spot when you transpose a number and a, yeah, right? That is 100% accurate. So we have reachability through Ingress replication. You know, that's a fair trade-off, Yvonne. That's a fair trade-off. Guess I can't really argue with you on that one. So now that we have that problem resolved, thank you to you guys that helped me resolve that problem. We have that included. So again, just to make sure everybody's on the same page, let's go ahead and let's scoot this up just a little bit so you guys can see this. We'll look at this on Nexus 9K1. I'll go ahead and open up this MAC address, and we can see that it is originated. We end up, this is a type 2 MAC advertisement route. It doesn't specifically say that, but if you've done any research on what routes are advertised in BGP, that's how you know. And if you look right here, you actually see a received label of 10,010. And the extended community value is the route target value is 65,001 or 65,101 colon 10,010. The encapsulation is 8. 8 means VXLAN. So it's a VXLAN tunnel. And if we look at the label value, we have 10,010, meaning that that's the VNI. And if you look up here a little bit, the VNI here is the route distinguisher we have is our route distinguisher is our loopback address, and then you have 32777. There is the RD starts at 32767, and for every VNI you add in this case here, it adds that value. So it adds the VNI value here to it. So don't remember specifically how that's stated, but that's along the same lines. So 32767, and then you add the VNI ID. That makes it 77. So that makes it unique. And then we have same thing here with 32778, the VNI of 10,011. So, but you can see that because we're using a different VNI, we have a different route distinguisher, which makes the routes unique, right? So technically two different subnets. So no different than two different customers. So we have that in play. Now, when we get into, we're going to jump into the Inter-VXLAN routing, and that is going to allow us to propagate layer 3 routes. So we'll be able to route in between the VXLAN networks via BGP. Not specifically via BGP, well, yeah, BGP will be used to advertise the routes. And then we'll be advertising a label for the layer 3 connectivity. So we'll take a look at that, how that comes into play. And that is actually rather involved. That process is not as simple as doing something like router on a stick or layer 3 switching. That process is actually kind of complicated. So it relies on symmetric integrated routing and bridging, and that concept in and of itself it's a little complicated if you've never dealt with it before. So I'll do my best to try to break it down for you, but what we're going to go do now is start at the layer 3 capability. And the way that works is we have to create a shared VNI between these guys. So right now we have VLAN 10 and 11 here, and VLAN 10 and 11 here communicating with one another. Everybody's happy. When you do traffic from 10 to 11, 10 to 10 and 11 to 11 is encapsulated inside a VXLAN. When you do a layer 3 VNI or the layer 3 gateway, you actually create another VLAN that's going to be shared just like these guys are, but you don't have to be shared on both sides. So you can have, 12 and 13 here and 14 and 15 here, but you'd be paired with other switches elsewhere in order to encapsulate the traffic in VXLAN. What we're going to do here is we're going to create VLAN 1000, and the VLAN 1000 is going to be configured with VN 1100, or sorry, 11,000. And what that's going to allow us to do is we're going to be able to create an SPI for 10 and 11, place it inside of a VRF that this VLAN is a member of. So we'll be able to, and that'll be done on both sides. So an SPI over here of 10 and 11, they'll join this VRF, which the interface VLAN 1000 will be inside of. And basically what we're going to do is when traffic comes into the 9K one that's inside of its VLAN, VLAN 10 or VLAN 11, if it needs to route between two different VXLAN networks, it's going to be bridged in this way, be a bridge into the switch. And then when the lookup is done, it's going to know that the destination you're trying to reach is a different VXLAN network. So then it'll actually route you to the shared VNI, which is this guy here. So it'll be your route. And then if you're on the same switch, you'll be routed in between VXLAN networks. So you'll be routed over here to the bridge. So if you come in as VLAN 10, you'll come in as 10, you'll be routed over to 1000, and then 1000 will route you to 20, and then 20, this will be a route as well. This one will bring you down into VLAN 20 as a bridge as you send traffic out towards the endpoint. So it's a bridge, route, bridge is how that process comes into play. It took a little bit of Wireshark capturing and some debugs to figure out exactly what that process looked like. It's not straightforward. This is not as simple as doing layer 3 switching, so you don't just turn IP routing on after you have your SPIs created and boom, everything just works. This is much more involved. So it adds in the VRF. The VRF is how we're going to do this. So just like, I forget who, I think it was Yvonne brought it up earlier about doing multi-tenancy. This is where multi-tenancy comes into play, where I can sit there and start doing customer 1 and customer 2. You'd have a VRF per customer, and if I wanted to route between VRFs, you can do VRF route leaking, but that's way beyond anything that I've covered yet. I know you can do it from the service provider studies that I've done. It can be done with the exports and imports and export maps and route maps and matching out prefixes and stuff like that. It's rather involved. But we're going to create VRF tenant 1, all caps, and I'm going to do an underscore IRB, so we'll know that it's used for routing. And then what we'll do is in VLAN 1000 for the SPI for 1000, we don't give this an IP address. Okay, so we use the command IP forward, which basically acts like an IP unnumbered. So it basically is going to grab the IP address of the local switch that you're doing the routing on. And then what it does is it forwards traffic that comes in from the source VLAN into this SPI, and then it forwards it to wherever it's got to go. So if it's got to jump across over to Nexus 9K3, there's a VXLAN encapsulation. So that's where VXLAN encapsulation will come in, is right here, between the route and the route. So you're going to VXLAN encapsulate it between the switches in order for that to happen. On the SPI for 10 and 11, what we're going to do here is we're going to give them a IP address we've already associated to like 7 and 8. So in this case here it'll be 10.1.10.254 and 11.254. What we do then is we place these sub SPIs into this VRF. And because they're going to be shared, they're going to be in the same routing table. They'll all be a member of the same RIB, and so they'll have visibility to each other. And that's going to be basically how you'll be able to go between one VXLAN network and another VXLAN network. And then what we have to do under BGP is we have to enable the VRF. So we'll go underneath BGP and we'll underneath the VRF, tenant 1 IRB. We'll create that, and then we'll enable the address family IPv4 unicast. And underneath the VRF, you also enable IPv4 unicast. And then what you end up doing is you take whatever subnets you want to advertise, so again 10 and 11, and you advertise them in BGP underneath the VRF aware IPv4 unicast peering, or the address family, and then that allows the information to propagate. So if you wanted to do external routing, for example, or do something down the road along, what do you call it? If you want to do like multi-site or bring external routes into the VXLAN fabric, this is how you would accomplish that. Now there's a couple ways of accomplishing on the border leaf when you're doing your external routing, for example, when you're doing this peering. On this link right here, this 10.3.15 network that technically isn't up and running at the moment, when you're doing the configuration there, for those of you that have ever dealt with MPLS Layer 3 VPNs with the back-to-back with VRF option, or option A, where basically each PE router is treating the other PE router like a customer edge, this is one of those scenarios where knowing that would come into play. Because what you can do is on this guy right here, you can create, I'm sorry, I should say the interface itself. You can go at the interface level and you can do sub-interfaces and put each one of those sub-interfaces into a different VRF. And then you can, this is where a multi-tenancy would come into play. You'd be able to make it multi-tenant based off the customer. So customer 1 would have whatever VLAN sub-interface, whatever VLAN ID associated to it, and then you'd be able to route between the border leaf and the external router through BGP, doing eBGP peering, and you'd be able to pull all that type of stuff off. So that's, I'm not going to have time to do that in this session, but that is an advanced capability that you're definitely going to want to take a look at and dive into. So we'll go ahead and get all of this dialed in so we can understand how it all comes into play. So I'm going to go ahead and pull up the config here. The first thing I'm going to need to go do is configure the VRF. So I'm going to create VRF context. I'm going to call this tenant 1_IRB for integrated routing and bridging. And then underneath here we have a number of commands that we need to type in. So I'm going to specify the address family is going to be IPv4 unicast, and then we can do the route target. Both will be auto. Cannot get virtual network ID from context 0. Okay, so we probably have to do the VNI first. So we'll do VNI 10010, and then the address family IPv4 unicast, and we'll do route target both auto. There we go. So there we have that. You can do the same thing for IPv6 if you want to do IPv6 propagation as well. We're going to hit the VNI 10,011. Please unconfigure first. Am I doing this wrong? I have to look at my notes. I've only literally done this one time. So I'm having to remember what the syntax was. Oh, okay, that's my mistake. Okay, so that's my mistake. Let me start over. VRF context. So if you're about to type something in the chat, you can type it in, but I realized the error of my way. VRF context tenant 1_IRB. This is going to be the shared. Oh, we have to wait for the completion of that. So let's go create the VLAN first. VLAN 1000, and we're going to say VLAN name is going to be VLAN 1000_IRB, and then we're going to say VN segment is going to be 1000 or 11,000, like that. And then we're going to exit out, and then we'll hit the VRF context command again. There it goes. We'll say VNI is going to be 11,000. The address family will be IPv4 unicast, and the route target both will be auto. There we go. So that's what we need to have. So now we have that piece in place. That's the one thing I forgot to do. That's where that comes in. So the next thing I'm going to go do is I have to create the SPI first. And I'm going to type in the feature interface VLAN. Do that Nexus 9K3 as well. So config T feature interface VLAN. On this guy here, we're going to type in interface VLAN 1000. We're going to type in VRF member is going to be in this case here, will be tenant 1 IRB. And then we'll type in no shut, and we'll type in IP forward. That's going to allow the communication of traffic from the other SPIs to come in here and just be used for transport. Okay, that's that. The other one we're going to go do is interface VLAN 10. We're going to type in no shut. Type an IP address here. It'll be 10.1.10.254/24. And then we have this one option down here at the bottom where it is the fabric forwarding mode will be Anycast gateway. This is what I was talking about earlier when I created the fabric forwarding Anycast gateway MAC address, that 0001 blah 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 blah. That's where this comes into play. If you don't apply that syntax to this configuration on both sides, what will end up happening is you'll get a duplicate IP address error or warning on both leaf switches. Okay, so they'll both be configured with the same SPI, the same IP address, and they'll detect that. So they'll detect it and they'll be like, well, I don't know what to do about this. So by using the fabric forwarding mode Anycast gateway, you're associating the same MAC address, and by doing that, they know that they won't have that duplicate MAC address or a MAC flap or that issue, the duplicate IP, that will go away. So that's that. So now I'm going to do the same thing for VLAN 11. VRF. Did I not put in the VRF? Show run interface VLAN 10. I did not. So interface VLAN 10. VRF member is going to be, I had to put in the tenant. That's what I forgot that. Let's put the IP address back on it. There we go. So show run interface VLAN 10. So interface VLAN 11. We're going to no shut it. VRF member is going to be tenant 1 IRB, and then the IP address will be 10.1.11.254/24. No shut. And then fabric forwarding mode Anycast gateway, and then we'll go to 10. Same thing. There we go. So now that we have all those steps in place and good to go, the last thing I need to go do is just verify some things real quick. Show run VLAN 1000. Show run VLAN. VLAN 1000 has been created. I need to show run VRF tenant IRB. The tenant has been created. Everything's looking good there. I need to go show run interface VLAN 10, interface VLAN 11. Okay, they're both good. The next thing I need to go is show run interface NVE1. And then underneath interface NVE1, I need to come underneath here and type in member VNI 11,000 and type in associate VRF, which is just going to allow that communication to go back and forth. And then I need to go underneath BGP, router BGP 65101, underneath VRF tenant IRB1, or tenant 1 IRB, and type in address family IPv4 unicast, and then I need to advertise 10.1.10.0/24, or I should say network 10.1.10.0/24, and then 11. All right, so now that I have that in play and everything's good to go, if I do a show IP route VRF tenant 1 IRB, I should see 10.1.10, 10.1.10, 10.1.11. I see all that type of stuff working, right? And that's local to Nexus 9K1. So now if I go over to router 7, assuming I've done everything correctly, if I ping 10.1.10.254, it should ARP for it and find it. If I do a show ARP, I should see a 0001, 001, so it's working. If I hit the up arrow and I do a 10.1.20.254, I'm sorry, there is no 20. That's my mistake. I meant to say 10.1.11. My mistake. That works. So I can ping to the SPI of VLAN 11. So if I ping to 10.1.11.8, I should also be able to ping router 8. There it goes. And now I can ping router 8. Now if I go over to Nexus 9K1 and I hit the up arrow, I should see additional MAC addresses or additional IP addresses showing up. I'll see 7 and I'll see 8. Right? That tells me everything's working for IRB. So now what I need to do is I need to take all the syntax and configuration I did on Nexus 9K1 and throw it on Nexus 9K3. So I'm going to go ahead and do a quick show run, and I'll just be able to pull the syntax out. I'm going to go ahead and pull up Notepad. And actually, no, I don't want to do that. Don't save. There's some proprietary information on that Notepad doc. So I'm going to go ahead and let's do a show run VRF. Show run VRF like that. We'll grab all this syntax right here. We're also going to grab VLAN 11. Let's do a show run VLAN. Do VLAN 1000. And then that's that piece. We'll do a show run interface VLAN 1000. Throw that piece in there. We'll do a show run interface VLAN 10. VLAN 11. Then we'll do a show run interface NVE 1. How long did it take you for you to wrap your head around MPLS? Huh, good question. Honestly, probably a year. Once I started digging into it, it started to make more and more sense. It wasn't until I started deploying it in the lab and trying to understand how it worked, but to really, really, really understand it well enough to where I could lab it up. I mean, a solid year to get good at it. Initially to understand it, probably a couple of months of labbing it up and understanding what it was trying to do. There's actually, so now that you asked, let me go ahead and pull up a real quick. This really helped me understand it. Let me look up Nanog. We're just actually watching this a little bit ago. Nanog MPLS. I was just watching this not too long ago, as a matter of fact. Let me grab the... hold on a second. Let me grab the... Can I share it? Share. Copy. I used this tutorial. This really helped me solidify my understanding. So take a look at that, and this breaks it down super deep, but also it starts at high levels and brings it down. You can also go check out, I have a long form video I did on this a while back. I also did a live stream a couple weeks ago on MPLS that dives into the config and talks about how it comes into play. So there's a bunch of videos I did on my channel for it. And then, so hopefully that'll help you out. And then with that, then we have to do the BGP piece. So show run BGP. And then I did the router BGP 65101. And then I did the VRF, did this. All right, so now that I've got all these pieces in play, so just from a top-down perspective and how this all comes into play, let me just throw the feature in here. Make sure that the feature interface VLAN is in there. So feature interface dash VLAN. Create the VLAN, associate the VN segment to it, then create the VRF context, give it a name, and then apply the VNI to it. Make sure that the IPv4 unicast address family is enabled. No worries, man. Then underneath the SPI, no shut it associated to the tenant, configure IP forward. And then interface VLAN 10, make sure you associate it to the tenant and the VRF, deploy fabric forwarding mode Anycast gateway. Do that for both whatever VLANs you're going to create. And then when you come down to the NVE interface, make sure you associate VRF to it and configure the SPI or the VRF underneath BGP. So I'm going to go do all that on Nexus 9K3. I'm just making sure I haven't missed anything. I think that's everything. So let me go ahead and copy this into Nexus 9K3 and paste. We're going to be sitting here for a few minutes, so just be a little patient. And then we'll test the connectivity. Okay, why did that not work? Oh, did I forget the BGP piece? Yes, I did. Router BGP 65101. We'll just repaste this right there in. There we go. All right, so now we have that. So show BGP L2 VPN EVPN. We come down here a little bit. We are going to have the layer 3 VNI. The layer 3 VNI is what we need in order for the propagation of information to happen. So now if I go back over here to 9 and 10, if I ping 10.1.10.254, I should be able to respond to that. That should respond. If I ping to 11, that should respond. And if I ping to 10, that should respond. There it goes. So now I can ping back and forth between the SPIs and everybody's happy. Now if I wanted to ping to, I'm on 9, I want to ping to router 8. Let's ping across that. That'll be VXLAN encapsulated. I can ping to that as well. If I go to Nexus 9K3 and I do a show BGP L2 VPN EVPN, I will see that information propagate right here. I see 8. And we have these routes right here. Type 5 are the... What is a Type 5 route? I forgot. One second here. BGP EVPN route type 5. I forgot what that is. Route type 5. So it's used to advertise IP prefixes for inter-subnet connectivity across data centers. That's right. I forgot about that. Yeah, so that's the route type 5 is the information between the subnets. I forgot about that. That's like one piece of information I should know, right, when I'm talking about this stuff. So that, ladies and gentlemen, is VXLAN up to this point. So now what's cool about this is if I wanted to do external connectivity, I can totally do external connectivity. I'd have to set this this router back up. It would appear with Nexus 9K3 or Nexus 9K1. I'd be able to do route propagation. And then I'd basically be able to take all the config that I did in this network, bring it over here to start playing with actually multi-site, which actually is the rest of my afternoon. I'm going to actually be going through that process and diving into those details because this is stuff that I want to go play with and get better at. So these are going to be some of the details that we're going to need to know in terms of getting traffic to where we need it to go and all that good stuff. So that's pretty much everything that I wanted to cover this afternoon. So we're right about that 2-hour mark. I want to thank everyone for hanging out and stopping by with me this weekend on this live stream. I will be taking some of the requests that I got for doing Flex VPN. I will be taking a look at that. My work schedule has dramatically slowed down, so I will be able to dive into. I want to get finished with the CCNP Enterprise series that I've been working on. I've got a lot of content to develop for that, as well as getting the labs written and uploaded to the drive for those of you that are repeat members. So I do appreciate your support and stuff like that. So I appreciate the feedback. Thanks, guys. If there's anything you would like me to do a demo on or lab up that I can possibly lab up and show you and answer any questions you guys might have on it, at least explain it to you the way I understand. Hopefully it makes sense to you guys. Please let me know. Follow me on Twitter. My Twitter handle is @RikerRob. Follow me on Twitter. It's something I definitely recommend everybody do because, well, at the end of the day, whenever I'm doing something, I'm usually tweeting about it. Any frustrations that I ran into and stuff like that. So there's a couple of additional things that I want to test out. One of those is adding firewalls to this solution. So I had to go play with that. I also want to try to get multi-site to work. And then I want to do VPC because right now I've gotten to the point where I feel comfortable with VXLAN. So with that being said, ladies and gentlemen, till next weekend. I know the Christmas holiday is quickly approaching us. So my goal is to have a live stream on Sunday, the 20th. But after that, I am out of town on vacation. So I will be out of town until probably the beginning of January. So we'll probably have one more live stream this year and go from there. If there's any requests, please leave me a note in Twitter. I will do my best to facilitate all that type of stuff. I'm going to be doing breaking up my videos now, so I'm not going to be just doing CCNP Enterprise. I'm going to be adding some other stuff in there because, to be honest with you, I'm getting to the point now where I feel comfortable doing. I mean, I did a live stream of VXLAN. I've never done that before, so feeling comfortable with this stuff, which is cool. So, at any rate, again, thanks everybody for stopping by and hanging out with me. I will see all of you guys next weekend. Same bat time, same bat channel. And yeah, that's it. I'm going to keep babbling if I don't get off here. So take it easy, guys. Thanks for stopping by.